Good day, grade 8 learners. Today, we're gonna discuss about Module 6, Lesson 1. Problem solving involving rational algebraic expressions. What I need to know. At the end of the lesson, you are expected to demonstrate understanding of the key concepts of problem solving involving rational algebraic expressions and solve problems involving rational algebraic expressions. Before we proceed to solving word problems, let's recall first our knowledge about rational algebraic expressions. Take note that in simplifying rational algebraic expressions, it is one way of reducing rational algebraic expressions to its lowest term. For example, we have here x plus 6 over x squared plus 5x minus 6. So, as a review, we need to factor out our denominator in this expression. So, we have x squared plus 5x minus 6. So, the factors of this expression is the quantity of x minus 1 times the quantity of x plus 6. So we have our new expression is x plus 6 over the quantity of x minus 1 times the quantity of x plus 6. Next, the next step that we're going to do is to cancel out the common expression in the common factor in the numerator and denominator. And we have here x plus 6. So we need to cancel it out. So therefore, the remaining factor will be 1 over x minus 1. So that is the simplified rational algebraic expression. Aside from simplifying rational algebraic expressions, we also need to recall our knowledge on operations on rational algebraic expressions. First is multiplying rational algebraic expressions with this formula a over b times c over d is equal to ac over bd, in which b and d should not equal to 0. So we have here, for example, 2x over 5 times 9 over 6x squared. So as we all know, in multiplying rational algebraic expressions, we just have to multiply numerator to numerator, then denominator to denominator of the expression. So we will be able to get 2x times 9 is equal to 18x, and 5 times 6x squared is equal to 30x squared. Yes. So we can still simplify 18x over 30x squared into lowest term. So all we have to do is just to get its greatest common factor. So the greatest common factor which is divisible to our numerator, which is 18x, and our denominator, which is 30x squared, is equal to 6x. So how did we get it? So for the numerical coefficient, we just got the greatest factor which will be divisible for the numerator and denominator. And for the literal coefficient, which is x and x squared, we just copied the variable which has the least exponent, which is x. So now let's simplify. 18x divided by 6x is equal to 3. And we have here 30x squared divided by 6x, so we got here 5x. So always remember our law of exponents. We also have dividing rational algebraic expressions following the pattern a over b divided by c over d is equal to a over b times the reciprocal of our divisor, which will be equal to D over C, which will result to AD over BC, where BCD should not be equal to 0. So we have here 12x squared y over 9a cubed b squared divided by 16xy to the power of 4 over 18a squared b. So applying the rule in dividing rational algebraic expressions, in which we have to multiply our dividend to the reciprocal of its divisor. So we will have our new expression 12x squared y over 9a cubed b squared times 18a squared b over 16xy to the power of 4. Take note, the reciprocal is the inverse of the fraction. And now we will be able to multiply following the rule in multiplying rational algebraic expressions, numerator to numerator, denominator to denominator. So we will be able to get 12x squared y times 18a squared b is equal to 216a squared bx squared y. Take note of our product rule. It is one of our law of exponents. Now let's multiply our denominator 9a cubed b squared times 16xy to the power of 4. So we will be able to get 144a cubed b squared xy to the power of 4. Once again, recall your knowledge about the product rule. So this expression can still be simplified to its lowest term. And we just have to get the greatest common factor, which will be divisible for both the numerator and denominator, and that is 72a squared bxy over 72a squared bxy. So we will just divide 216a squared bx squared y divided by 72a squared bxy, we will be able to get 3x. So applying the quotient rule, so we just only subtract those subtract those exponents with the same base. And also we will divide our denominator 144a cubed b squared xy to the power of 4 divided by 72a squared bxy. The answer is 2aby cubed. So that is our final answer. We also have to remember adding and subtracting similar rational algebraic expressions. Following this pattern, a over b plus c over b is equal to a over c over b, wherein b should not be equal to 0. So we have here 2a over ab plus ac plus 3a over ab plus ac. So as you can see, they just have the same denominator. That's why it is similar rational algebraic expressions. So all we have to do is just to copy the denominator, which is ab plus ac, and then simply add our numerator and denominator, which is 2a plus 3a. So we will be able to get 5a over ab plus ac. And as you can see, we can still factor out our denominator ab plus ac. We will be able to get the a times the quantity of b plus c. So as you can see, we just have to check if it will just be equal to ab plus ac by applying the distributive property. So a times b is ab, then a times c is equal to ac. So this is the factor of ab plus ac. So our new expression will be 5a over a times the quantity of b plus c. And take note, we can still cancel the common factor in the numerator and denominator, which is a. So we can just cancel it. So our final answer for this expression is 5 over b plus c. You also have to remember adding and subtracting dissimilar rational algebraic expressions, in which you have to change the rational algebraic expressions into similar rational algebraic expressions using the LCD and proceed as in adding or subtracting similar fractions. Let's take this example. 5 over 18a to the power of 4b plus 2 over 27a cubed b squared c. So as you can see, they don't have the same denominator, so we have to get the LCD. So the LCD is 54a to the power of 4b squared c. And take note, in getting the LCD, we have to get the multiples, the least multiple that will divide 18 and 27. And also for this expression, we have to get the variables which have the greatest exponent. So that's why we have 54 as our numerical coefficient of our LCD, and a to the power of 4, b squared, and c as our literal coefficients of the LCD. Now what we are going to do is just to divide our LCD by our first expression with the denominator of our first expression, which is 18a to the power of 4b, and then multiplied by our numerator, which is 5. So we will be able to have 54a to the power of 4 b squared c divided by 18a to the power of 4b. Applying our quotient rule, we will be able to get 3, and then multiply with our numerator, which is 5, so we will be able to get 15bc. Next, we will have to divide 54a to the power of 4b squared c to 27a cubed b squared c. So we will be able to get 2 times our numerator, which is 2, so we will have 4a. So our expression will be 15bc plus 4a over 54a to the power of 4 b squared c. And take note, we can't simplify this one anymore, so this is already our final answer. Now let's proceed to our final review of the operations and rational algebraic expressions, which is simplifying complex rational algebraic expressions. So in simplifying complex rational expressions, all we have to do is just to transform it into a simple rational expression, just like this example. We have here 2 over a minus 3 over b all over 5 over b plus 6 over a squared. So in this complex rational algebraic expression, 2 over a minus 3 over b is our numerator, and 5 over b plus 6 over a squared is our denominator. So the first thing that we're going to do is to simplify our numerator by getting the LCD. So we will be able to get the LCD of AB, and then we have to divide AB to the denominator A, so it will be equal to B, and multiply to the numerator 2, so that's why we got 2B. Next is to divide AB to B, so we will be able to get A, and multiply to the numerator 3, so we will be able to have 3A, and just copy the operation, which is subtraction. After that, we also have to simplify our denominator by getting the LCD. So in this case, our LCD is a squared b. And then same with what we have done in the numerator, we just have to divide a squared b by b, and then multiply to the numerator 5. So we will be able to get 5a squared. And So we will also still divide a squared b by a squared and multiply to the numerator 6. So we got here 6b. And take note that in simplifying complex rational algebraic expression and in getting its LCD, we have to remember the quotient rule, especially in dividing and product rule for multiplying variables. Now let's simplify our numerator. So we will be able to get 2b minus 3a over b all over 5a squared plus 6b over a squared b. And take note that applying the rule in dividing rational algebraic expressions, we have to multiply our dividend to the reciprocal of our divisor. So the reciprocal of this divisor. So our new expression will be 2ab minus 3a over ab times a squared b over 5a squared plus 6b. Now, applying our rule in multiplying rational algebraic expressions, so numerator to numerator and then denominator to denominator. So we just have to combine first. So we will be able to get the quantity of 2b minus 3a times the quantity of a squared b over ab times the quantity of a squared plus 6b. And take note that there is a common factor in the numerator and denominator. So we can just cancel b. Yes. And applying the quotient rule, then we will be able to get the quantity of 2b minus 3a over a. So it became a as we subtract a squared and a over 5a squared plus 6b. So our new expression will be the quantity of 2b minus 3a times a over 5a squared plus 6b. So in this case, our final answer would show the expanded expression in the numerator. So it will be equal to 2ab minus 3a squared, in which we just distribute a to our first term and second term using the distributive property of multiplication. So that's why we got 2ab minus 3a squared over, just copy the denominator, 5a squared plus 6b. So that is our final answer. That is how to simplify complex rational algebraic expressions. Just take note that the skills in performing the operations on rational algebraic expressions is one of the key concepts in solving rate-related problems. And that is what we are going to have in this module. What's new? So let's take a look of this problem. Two vehicles traveled x plus 4 kilometers. The first vehicle traveled for x squared minus 16 hours, while the second traveled for 2 over x minus 4 hours. What is the speed of each vehicle? So how are we going to answer this problem? And that is what you're going to do as we move on to the next pages. What is it? So in solving word problems, you have to remember the steps. So these are the steps in solving problems involving rational algebraic expressions. First is you have to read and identify the problem. Second, you have to gather information from the problem. Third, you have to create an equation. Fourth, solve the problem. And the last one is finalize and check your answer. So let's have this first example. Two vehicles traveled x plus 4 kilometers. The first vehicle traveled for x squared minus 16 hours, while the second traveled for 2 over x minus 4 hours. Now, what is the speed of each vehicle? So the first step in solving word-related problems is to read and identify the problem, and that's what we had done a while ago. So that second step is to gather information, and based on the problem, we will be able to get the following information, such as two vehicles, so the number of vehicles, the distance that they have traveled, or in kilometers, and also the time that they have traveled, and also we need to have this information which is unknown, and that is the speed of each vehicle. Take note that based on the problem, we were able to know that there are two vehicles in the problem which traveled a certain distance. So for those two vehicles, we can assign it as vehicle A and vehicle B. And take note, for the distance covered, it was also given that for vehicle A, the distance is x plus 4 kilometers. And for the vehicle B, the distance is also x plus 4. Because as stated in the problem, two vehicles traveled x plus 4 kilometers. So they have the same distance. But for the time, they already differ from the time. So for vehicle A, the time is x squared minus 16 hours. And for vehicle B, the time is 2 over x minus 4 hours. And the speed was unknown. So we need to find out the speed of vehicle A and vehicle B. The third step in solving word problem is to create an equation. And based on our problem, our unknown is the speed. And take note that a speed, in getting the value of the speed, it has the formula of S is equal to D over T, in which D stands for the distance and T stands for the time. So for the first vehicle, our distance is x plus 4, and our time is x squared minus 16. And following our formula, S is equal to D over T, we will be able to get the equation S is equal to x plus 4 over x squared minus 16. And for our second vehicle, we will be able to have the distance of x plus 4 and the given time, which is 2 over x minus 4. So our equation is equal to S, or speed is equal to x plus 4 all over 2 over x minus 4. So these are the equations for vehicle A and vehicle B. And now we just have to find the speed. The fourth step in solving word problem is to solve the problem itself. So let's solve first our vehicle A. So let's find its speed. So we have here the equation S is equal to x plus 4 over x squared minus 16. And remember the way of factoring polynomials. So we will be able to factor our denominator. So how to do that? We have to factor out the denominator using the difference of two squares. So as you remembered in the previous modules, the difference of two squares is following this formula: a squared minus b squared is equal to the quantity of a minus b times the quantity of a plus b, in which to get the value of b, we just have to extract the second term. And for the a, we just have also to extract this first term, which is x squared. So we just have to get the square root of x squared, that is equal to x, and the square root of 16 is equal to 4. And following this formula, we will be able to get the expanded denominator, which is the quantity of x plus 4 times the quantity of x minus 4. On our numerator, we just have to copy that one, so still x plus 4. So our new expression will be x plus 4 over x plus 4 times the quantity of x minus 4. And then take note that we can still cancel the common factor both in the numerator and denominator. So we can cancel x plus 4. Take note that as we divide x plus 4 divided by x plus 4, the answer will always be 1. So our final speed for vehicle A is 1 over x minus 4. Now let's proceed to solving the speed of our second vehicle, our vehicle B. We have here the equation s is equal to x plus 4 all over 2 over x minus 4. As we all know, s is equal to x plus 4 all over 2 over x minus 4 can also be written as x plus 4 over 1 divided by 2 over x minus 4. And in solving for this equation, we have to apply the rules in dividing rational algebraic expressions, in which we have to find the reciprocal of the divisor, then proceed to multiplication. And the reciprocal of 2 over x minus 4 is x minus 4 over 2. So, applying the rule in dividing rational algebraic expression, we will be able to have x plus 4 over 1 times x minus 4 over 2. Now, let's multiply numerator to numerator, denominator to denominator. So, we will be able to have the quantity of x plus 4 times the quantity of x minus 4 over 1 times 2 is equal to 2. So by using the FOIL method for the numerator, we can expand this one. So applying the FOIL method, first x times x is equal to x squared. Or yes, x squared. Then O outer, so x times negative 4, it's negative 4x. And we will be able to have the inner next is 4 times x, so positive 4x. And the last is second term to second term, so we have positive 4 times negative 4 is equal to 16. And we combine like terms, so negative 4x plus 4x is equal to 0. So we will be able to get the answer x squared minus 16 over 2. And that is the speed for vehicle B. The final step in solving word problem is to finalize and check the answer. And we were able to get the value of the speed for vehicle A and vehicle B. For the vehicle A, it has the speed of 1 over x minus 4 km per hour, while the vehicle B has the speed of x squared minus 16 over 2 km per hour. And let's check if it is correct. So to check if the answer is correct, so we have here our vehicle A, and its original equation is S is equal to x plus 4 over x squared minus 16. So all we have to do is just to substitute the value of our S, or our speed, which is 1 over x minus 4 equals x plus 4 over x squared minus 16. And now, we have to cross multiply. So we have to cross multiply 1 and the numerator 1 to the denominator of the opposite expression, which is x squared minus 16. And also the numerator x plus 4 to its opposite denominator, x minus 4. So we will be able to have x, the quantity of x plus 4 times the quantity of x minus 4 is equal to x squared, the quantity of x squared minus 16 times 1. And so let's simplify. We will be able to get x squared minus 16 here at the left side and x squared minus 16 at the right side as we multiply. X squared minus 16 times 1. So since the left side and the right side is equal, therefore our speed, which is 1 over x minus 4, is correct. Now let's check if the answer for the speed of the vehicle B is correct. So our original equation is S is equal to x plus 4 all over 2 over x minus 4. So we just have to substitute the value of S. So we will be able to get x squared minus 16 over 2 is equal to x. So take note that this is a complex rational algebraic expression. So we have to apply our learnings in dividing rational algebraic expression. So we have to multiply to the reciprocal. So our new equation is x squared minus 16 over 2 is equal to x plus 4 over 1 times x minus 4 over 2. And now let's simplify the right side. So we will be able to multiply numerator to numerator and then denominator to denominator. So we got here the quantity of x plus 4 times the quantity of x minus 4 over 2. Now let's do the cross multiplication. So cross multiply x squared minus 16 and 2, and then 2 times the quantity of x plus 4 times the quantity of x minus 4. So we got here 2 times the quantity of x squared minus 16 at the left side, and to the right side we have here 2 times the quantity of x plus 4 times the quantity of x minus 4. So applying the distributive property of multiplication, so for the left side we distribute 2 times x squared is 2x squared, and 2 times negative 16 is negative 32. And for the right side, we have to factor this one. So using the FOIL method, and after that, we will distribute using the distributive property of multiplication. So the answer is, for the right side, is also 2x squared minus 32. Therefore, the left side and the right side has just the same answer. So the speed, which is x squared minus 16 over 2 for vehicle B, is correct. And that is how you finalize and check your answer. And now let's proceed to the second example. So we have here 7 divided by the sum of a number and 2 is equal to half the difference of the number and 3. So the unknown is find all such numbers. So don't forget the steps in solving word problems. So read and identify the problem is the first step. The second step is to gather information. So we got here 7 and then divided by the sum of a number. So we need to know what is that number. and then 2 is equal to half the difference. So those are the information that we were able to gather, and the unknown is those numbers. What are those numbers? Now let's create an equation based on the problem. So since we don't know what is that number, so we can just assign that number to any variable in the alphabet. So in this case, we will be having x as that assigned variable, which will be equal to the number. So from there, we will be able to create our equation. So recalling your knowledge in translating verbal phrases to mathematical phrases, so we will be able to get 7 divided by, so with this symbol over, by the sum of a number. So by the sum of a number and 2. So therefore, we assign the number which is equal to x, and following the operation stated, the sum. So we will have add, then sum of a number and 2. So we got x plus 2 is equal to, so we have here sign, equal sign, half the difference of the number and 3. So we will be able to have here half. So it means it's 1/2. 1/2. So there is an imaginary 1 there. So 1/2 of the number. So we can just have it as 1/2 x. So the number means x. And 3. So it means we have here subtraction because of the word difference. So our equation will be 7 over x plus 2 is equal to x minus 3 over 2, or simply 1/2 x minus 3. Take note that the x in the denominator should not be equal to -2 because that would make the denominator 0. So if the denominator will become 0, then 7 over 0 will be undefined. So make sure to take note of that. Since these two rational algebraic expression is proportional to each other, so we just have to cross multiply 7 and 2, and then x plus 2 and x minus 3. So we will be able to have this equation. So 7 times 2 is equal to the quantity of x plus 2 times the quantity of x minus 3. So 7 times 2 is equal to 14, and for the quantity of x plus 2 times the quantity of x minus 3, we just have to apply the FOIL method. So we will be able to get x squared minus x minus 6. So how did we get x squared minus x? Again, the FOIL method. So x times x is equal to x squared. O means outer, so x times -3, it means -3x. Inner is positive 2 times x, so we will have plus 2x. And the last one, 2 times -3 is equal to -6. And as we combine like terms, so we got here x squared. So -3x plus 2x, the remaining is -1x, or you can just simply write -x. So that's why we got here x squared minus x minus 6. We need to know the value of the number or the value of x based on the given or based on the problem. So we need to equate this expression into 0. So how are we going to do that one? So we just have to add the additive inverse of 14 to both sides, so to the left side and to the right side of this equation. So we will be able to get negative 14 plus 4. So the additive inverse of 14 is negative 14. So that's why we have here negative 14 plus 14 is equal to x squared minus x minus 6 minus 14. So we add to the additive inverse. Will be 0 is equal to x squared minus x minus 20. So negative 6 minus 14 is negative 20. Remember the rule in adding or subtracting integers. So next is we have to factor out the quadratic trinomial x squared minus x minus 20 and equate each of the two factors to 0. So we will be able to get the factor of x squared minus x minus 20 is x minus the quantity of x minus 5 times the quantity of x plus 4. So to get the factor, so we were able to get the factor negative 5 and 4. How did we get it? So we just look for factors of the third term, which is negative 20, and then that factor, as we will add that one, it will equate to negative 1. So the factors which will equate to that are negative 5 and 4. So negative 5 and 4. So in which as we multiply negative 5 and 4, we will be able to get negative 20. And as we add negative 5 and 4, we will get negative 1. So that's why our factors are negative 5 and 4. We cannot have the other factors of 20 like 1 times 20 or 4 times 5 because it will not equate to negative 1 in the middle term. So take note of that. Be careful of the signs. So we will be able to have the result of the quantity of x minus 5 and the quantity of x plus 4. And now we have to equate both to 0. So it will now have x minus 5 minus 0 and x plus 4 is equal to 0. So to get the value of x, so we just have to add the additive inverse. So we will be able to get x minus 5 is equal to x is equal to 5 and x plus 4 will be x is equal to negative 4. So these are the value of x. Now the final step is to finalize and check the answer. And as the result a while ago, we were able to get the numbers which are 5 and negative 4. Now let's start checking if the answers are correct. Let's start with 5. So let's check if x is really equal to 5. How? So we just have to substitute the value of x to the original equation, which is 7 over x plus 2 is equal to x minus 3 over 2. So let's substitute the value of x, which is 5. So it will now become 7 over 5 plus 2 is equal to 5 minus 3 over 2. And now we're going to simplify the value in the numerator and denominator of the first fraction and the second fraction. So we will be able to have 7 over 5 plus 2 is equal to 7. Yes. And 5 minus 3 is equal to 2 over 2. And take note that 7 divided by 7 is equal to 1 and 2 divided by 2 is equal to 1. Since our left side and our right side has the same answer, therefore x is equal to 5 is one of the numbers. And it is correct. So we're then checking for x is equal to 5. Now let's proceed to checking if the value of one of the number is negative 4. So x is equal to negative 4. So let's base it from our original equation. 7 over x plus 2 is equal to x minus 3 over 2. So we just have to substitute the value of x this time, which is negative 4. So the substitute value is 7 over negative 4 plus 2 is equal to negative 4 minus 3 over 2. And we just have to simplify. 7 over negative 4 plus 2 is equal to negative 2. Then negative 4 minus 3 is equal to negative 7 over 2. Remember the rule in adding and subtracting integers, especially the same and not the same signs. And now, take note that 7 divided by negative 2 could be equal to negative 7 over 2, and negative 7 divided by 2 is also equal to negative 7 over 2. Therefore, x is equal to negative 4 is the correct answer, since our left side and our right side has the same value. So that is how you finalize and check your answer. Alright, so I believe you are now able to understand how to solve problems involving rational algebraic expressions. So now, I know you can already answer these problems. What's more, Activity 1. Directions. Read the problems carefully and answer using your own knowledge in simplifying rational algebraic expressions. Follow the steps suggested above for you to be guided, so don't forget those steps. And here are the problems. Number 1. Aina has 3x over 2 oranges. Her friend Aliana has 5x over 2 oranges. And Adeline has 7x over 2 oranges too. How many oranges do they have in all? Number 2. Ida has 5y minus 4 over 3 slices of cake. She gave y over 4 to her little sister. What part of the cake was left to Ida? Number 3. Shane has x plus 5 over 35 chocolates. She wants to divide it to her x squared plus 6x plus 5 over 7x friends. How much should each one receives? Number 4. The cost of ball pen in the canteen is x over x minus 2 pesos. If Sharina wants to buy x squared minus 4 over 2x squared plus x pens, then how much will she pay? Number 5. An isosceles triangle has two sides of length 9x plus 3. The perimeter of the triangle is 30x plus 10. Determine the ratio of the perimeter to the base. So those are the 5 items that you have to answer as part of your exercises. So don't forget to, when you answer those problems, you have to remember these steps in solving problems involving rational algebraic expressions. So the first thing that you have to remember is to read and identify the problem. Next is to gather information from the problem. Third is to create an equation based on the given information. 4 is to solve the problem. And 5th is to finalize and check the answer. I believe you will just be able to answer it. I know you can do it. So as we end this lesson in this module, I will leave you with this quotation from Herman Melville. It is better to fail in originality than to succeed in imitation. So I hope you will really try your best answering your activities on your own. And that's all for today. And I hope you learned something from this lesson.